So first thing first is that we see this, but we only understand on the previous episode, which I'm gonna actually talk about, which is basically talking about how the logic sense works in every sense of things. So first thing first is that they're saying that duplicate, and that you can't do that. So for this and this, they can't occur. So when they detect a duplicate, they just kind of like remove it, I'll say. So if they remove it, the logic sense is that they want to get the idea is this, the end product. So intuitively, I get the thing is at the start it doesn't like have the sorted sum, so I'm not sure why it got transitioned like intuitively into like a sorted array as opposed to just this question mark. But anyways, this it will become like 4. So I actually don't know how to move already, like what the hell. But for the latest problem, I just feel that I just only got a recollection of. So but for some reason they are taking this, okay, and then they started doing a 2 sum over here for some reason, okay. So I mean 2 sum will basically start from 2 edges. So this and this, what we need to get is like a positive tree. So this too too big, I think. So I put here this, but in my opinion it's like a duplicate. Can we use have duplicate given an array norms of n integers? Are there element a, b, c in nums such that a 0 5 unit triplets? Yeah. So I can't use this. If this is this use, this can't use. So we start from here. This 5 too big, let's say. So too big, I move this. Too big, I move this. So we actually find it. So it's this. So first and foremost, they use this, and then the 2 sum to actually find this. So, but what if I brute force it? So in some way they actually check like if there's like duplicate for this. So I check this cannot. So I check with this, then check with this, check with this. I think rinse and repeat. As I'm checking like this, I check for duplicate as well. So over here straight away I don't consider this. So it's a bit of like n square time complexity, way of n square. Yeah, that's how I actually understand from it, for the first part. So if they explain in the first part is this way, I think that's how I actually recall it to be. And when they actually talk about the time complexity for this whole thing, because they narrow it, the first thing first is that they sort it, so it's n log n, the n square I know they do this, but and then they do the 2 pointers. unless this thing is saying that the n, this is n, is because it will go for, it will go this set A referring to this two pointer of a set of the second set, which is this, and then they move on to the second set, and then this is set B, this and this, set C, this and this, set D, this and this, and rinse and repeat. So it's like n multiplied by n. That's why n squared. That's how I believe it derived the n squared for this, because this is bigger than this, then big of n squared. In terms of space complexity, first thing first, I don't think that we can derive to talk about the time and the space, because I'm not too sure about the whole mechanics of how this thing works. So I just gonna say that I'm gonna predict the time only, but for space, big O of 1, big O of n. I think the main problem is that I don't know the main mechanics. That's why I don't really understand how to go from here. So yeah, everything comes to an end.